Hello and welcome to the very last video of the DIY Collective series. Today we will be installing the firmware for the collective, the software that controls all the buttons and the movement of the collective. And I'm gonna share the file of course with you, but I need to show you what everything does because you will probably have to modify some of the things to your needs. There are some things that you may need to tweak. So without further ado, let's go on with it. First thing you will need obviously is the Arduino IDE. Since we are using an Arduino board, you will need the software to upload the firmware, and that is Arduino IDE. I will leave a link in the description of anything that you will need and everything that we will talk about in this video. But the most basic thing, of course, is the Arduino IDE. So let me just show you how it looks like. So this is the IDE. I have the dark mode. Anyway, so when you open this is a blank sketch. This is not going to be a tutorial on Arduino, so I'm gonna assume you already know some things, though I'm gonna explain some other things. But once you open the IDE, you will see this, and the first thing you would need to do is to set up both the board that you are going to use and the port that board is at. So in this case, you will need to go to Tools, and the board, you can see here I already have selected the Arduino Pro Micro, but if you didn't, you would select it from this list here. Actually, yeah, don't get it confused with the Arduino Pro or Pro Mini. It's the Micro one. If you bought a Chinese Knockout, it could be also a Leonardo, but it doesn't matter which one you select because they both use the same bootloader, so any of them should work. In any case, when you actually the port here, it says COM12 because I had already mine plugged in, but if I don't have it plugged in now, as you can see, it's not plugged in. This port COM1 is something else in my computer. The moment you plug it to the computer, you will hear the tone, and you will see that a new port has appeared. And as you can see, it already tells you what kind of board it is in case you were not sure if it was a Micro or a Leonardo. So you would select the port and also the board, which is already selected in my case. At this moment, we are able to upload a firmware. The firmware, as I mentioned, I'm gonna share. I have it here in my desktop. So just let me open it. So this is all what you're going to need. This is the firmware, and let me go through it and explain you some of it, especially the parts that you need to modify. But essentially, yeah, let me go through the code and explain what each line does. So the first thing that we will need to do is include a few libraries. The first one, joystick library, as I said, I will add all the links to the libraries as well in the description. The first thing is the joystick library. This is the one that tells the computer that the device that you have just plugged in is a gaming device, and that will make it so Windows will automatically identify it as a gaming device with all its buttons and axes and all that. The second and third libraries. The first one you will not need to install it; it's already installed by default, but you will need to install this one. This is to control the PCB boards, the PCF boards, the port expanders, these ones here. Remember, we have two of them. So the next step here is to declare them and tell them what's the address. So if you remember from previous videos, let me show you. These boards have an address. One second, because I need to manually focus it. There you go. So if you remember, these boards have some paths here that you need to bridge either to ground or to VCC to give it an address. In this example, this one, for instance, has A0 ground to VCC. You cannot see it, but there are three paths here: one on top, one in the middle, and one in the bottom. So in this case, the middle one is bridged with VCC. The top one, sorry, A1 is bridge to ground, and A2 is bridge to ground as well. So in this case, this board has an I2C address of 0x21. In my case, and if you did the same as I did, you'll have the same. I have one with all three paths bridged with ground, and one exactly like this, which that means that you have these two addresses, right? So one of the boards has this address, I2C address, and the other one has this address. We need to differentiate the two of them. Then this is not relevant. The next lines, we need to tell Arduino where are we, where did we plug all the analog inputs, and analogs are essentially this movement here and the joystick here. So y axis and x axis. So y axis, x axis, and this. So there are three analog inputs in this device. And if you remember from previous videos, the main collective movement, so up and down, is connected to pin A3, and then the joystick, the thumbstick, both axes are to A2 and A1. For now, I've just set X as A2 and Y as A1, but this is one of those things that you may need to change, and we will see that later on. The next line is essentially setting up the joystick device. It's the line that the joystick library needs. You don't need to know much about it. It's just a very quick explanation. This 37 here is the number of buttons that the collective has, and then all these statements, true and false, are the axes that the joystick have. So we are only using three axes, as I just mentioned, three analog inputs. So there's only three statements as true. You could have a few more in a different device. Next, we declare a few variables that we will need. Don't need to worry about this. The next one is a matrix that provides all the button IDs. You also don't need to worry about that. The next one is a matrix where we will store the status of all the buttons. Don't need to worry much about it, but just so you know, if you remember from previous videos, with the two expander boards, we are pulling values up. That means that they are at 0 value by default, and when we push the button, that makes a connection with VCC and makes that button read a high value. So by default, they are at 0, and when you press the button, they are at at 1. However, the 5 buttons that we didn't plug to the boards, because we ran out of ports or pins in the boards. If you remember, we plugged in 5 of the remaining buttons directly to the Arduino Pro Micro, and these 5 are those. And those buttons, we are pulling them up because it's better to do that. Sorry, pulling them down. So that means that unlike the expander boards, what we are doing for the other 5 buttons, they are on a high status by default, and when we press the button, we connect them to ground, and that pulls them down, meaning that when we press those 5 buttons, we go from 1 to 0. So that's why their default state is actually 1. Don't worry about it because you won't need to change any of this. So now we go to the setup. So the first statement is a debugger. So you will need this serial begin to be able to see some of the values in the Arduino monitor, and we will see that in a moment. But once you have set all your values, if you want, you can delete this line. Next one, we are declaring the 5 independent pins, which, if you remember from the previous video, I soldered those pins, those buttons in pins 5 to 9 in the Arduino. So what I'm doing here is a for statement, which means this statement is repeated as long as these conditions are met. And we are setting that pin as an input pull-up. And this means that the board, when you plug it in, will set these pins from 5 to 9 by default as high. And then we need to do the same for the 2 boards and declare all their pins, in this case as inputs, because as we mentioned before, we are pulling them up. So from pin 0 to pin 15, in this case, is smaller. So pins don't go from 1 to 16, they go from 0 to 15. For board 1, we set them all as inputs, and then we do the same for the second board. And then we need to initialize both the expander boards and also the joystick itself. So that's all the setup you need. Then we go to the loop function, and to make things a little bit tidier, I just prefer to have it in different functions. You could just copy all the code inside the loop, but I just prefer to do it this way. And we will have 2 functions, one that will check the state of all the buttons and one that will check the state of all the analog axes. So let's go with the buttons first, which is this function here. You can just copy paste this and there's nothing to change in here. The next one is actually the analog inputs, and this is the one that you may need to do some tweaking. And that's why we have some serial print commands that I'll show you what they do very, very soon, because we need to see what these readings are. Let's upload this sketch as it is and see what each one of these analog readings does. So we click on upload. First thing, it compiles the sketch and then it uploads it. Okay, so now that the sketch has been uploaded, if we open the device manager, the gaming device manager from Windows, you will see that I have my pedals plugged in, but also there's another device plugged in. And this is the Arduino Micro, the one that we just created. If we double click on properties, we see not all the buttons because Windows only goes up to 32, but we see all the axes, which are the X, Y, and accelerator. This is the one that we're using for the up and down movement. In this case, you can see, so this is the very top position, and the accelerator is at the bottom. And if I move it up, the accelerator goes up. But depending on how you solder in the potentiometer inside the gearbox, it could be doing the other way around. It could be it could be upside down. Also, if you remember, we are not using the whole travel of the potentiometer because we don't want to apply pressure to that potentiometer. The pressure is applied on the plastic part of the gear. So there's a little bit of value that gets lost in the movement. So if I go all the way up, you probably cannot see it, and I'll use something else very soon. I'll show you, but it's not all the way up in here, right? And same thing if I move the thumbstick, I'm moving it all the way up and down, and it's not at the very end. Let me just close the Windows Device Manager. I just wanted to show you that it displays as a gaming device. But for this type of projects, since Windows only, as I mentioned, displays only 32 buttons, and this collective has more than 32, you wouldn't be able to check that all the buttons work. So, but all of them are actually there. It's just Windows is not displaying it. So for that, I use a little program, very useful. I'll put a link in the description as well, which is Pointy's Joystick Test. And this one displays exactly the same information with all the inputs. I've tested this with a Dirac that has over 80 buttons, and it can display all of them. It can display up to, I don't know if there's a limit, but it can display all the inputs. So in this case, you can probably see that the potentiometer of the collective doesn't go all the way to the bottom. And if I put it all the way up, it also doesn't go all the way up. And that's due to that little margin that we did. And same here with the thumbstick, you can see it doesn't go all the way to the limits that it could go. So why is that? What do we do to fix it? So essentially, this is what this is for. We need to read something. I want to also show you is that if I move the thumbstick left and right, that should be the x-axis. And if you see, let me show you. I move it left and right, but the input is actually going up and down. And if I move it up and down, it should be the y-axis, but instead it's doing the left and right. So to fix this, we just need to change. This only means that we wired the x-axis to port analog 1, A1, and y-axis to A2, right? So since we didn't know it until we uploaded, we need to switch this. Then let's upload it again. I need to close this and open it again. And now that the sketch has been uploaded again with the new data, if I move left and right, you can see the axis is moving left and right. If I move it up and down, oh, so it moves in the y direction, but as you can see, it's moving backwards. So if I go down in the thumbstick, the axis goes up, if I go up, the axis goes down. So let's fix that. So how do we fix that? Here we have a function that I removed it for the X and Y, but looks like we are gonna need it for the Y axis, which is the mapping. And what will we do with this? So analog readings go from, let me change this variable name, Y axis, and also Y axis. So by default, analog devices, Arduino reads them as values from 0 to 1023, right? So what we need to do is reverse that, because we saw that it's reading it the other way around. So we use the function map to go and read. Arduino would be expecting 0 to 1023. We are gonna tell him to do it the other way around. So convert 0 to 123 to 1023 to 0. If we just do this and upload the sketch, so now that we have uploaded the sketch again, we can test it once again. And if you see, if I push the thumbstick up, now it goes up. And if I push this thumbstick down, the device goes down. So now what we have to fix is the fact that it doesn't do all the trouble. And as I mentioned, that is because it's not doing the entire physical trouble inside here. So let's start with the throttle, and what we need to do is read what is the potentiometer outputting. So what is actually Arduino reading? And to do that, we are going to use the serial print. So as you can see here, we have the analog read for that pin. We're going to uncomment this command and submit again. This serial print, what it does is print in the serial monitor this reading. So if I open the serial monitor here in the tools menu, serial monitor, so now you can see that the very minimum value of the collective is between 10 and 11. And the very maximum one, when we move it all the way up, is 995. So between, I'd say 11 and 995, 96. So let's give it a little bit of room. And here in the map function, we need to change that to those values. So we are telling Arduino, you are reading from 10 to 996, and you need to convert that into 0 and 123. So if we upload that now, and check again the tester, we can see that the collective goes from 0 to 100. Now, we need to fix the thumbstick as well, because as you can see, it goes in the proper direction, so left, right, up and down, but it's not reaching the limits. And the reason for that is because of the plastic. Let me show you. So as you can see, the cap of the of the thumbstick, let me just focus, is colliding with the plastic, as you can see. So what we need to do is read what are the minimum and maximum values and also convert them. So to do that, we can already comment out the throttle reading. We don't need that anymore. And we can uncomment the X and Y axis. We need to uncomment the X axis reading. We uncomment this, which is essentially a space, to have a space between X and Y reading. We uncomment the Y reading, and we also need to change this command from print serial print to serial print ln in order to have one reading per line. So now we can upload this. And as you can see, we have all the X readings to the right and the Y readings to the left. So we need to convert, to map, sorry, let me just copy paste this mapping function. And then this is the X-axis. Don't forget to change the variables. X-axis, we need to go from the minimum value, which is, and play a little bit around to make sure you are all the way farther to the right. It's 118. So 118 to the very farthest to the right value, which is 823. 823, and this is in the proper direction, so we need to make it from 0 to 1023. So convert 118 to 0 and 823 to 1023, and the same for the y-axis. Okay, I know what's going on here. We need to make the reading before the conversion. So we move the reading code on top of the map code and read again. So let's do that, because we are converting this value and then reading it. We should be doing it the other way around. So maximum value is 873. Is this one, and then minimum value is 222. Let's see if that works now. Yeah, so now it's working. Now that the analog inputs are ready, the only thing left to do is test the digital inputs, the buttons essentially. So we will go through all of them just to make sure. And as you can see, all of them work. Trigger. Yeah. So there you have it. Now we have a working collective that we can use in DCS. We can use in any other games actually, because this is a gaming device. If we open up the Windows gaming device, you can see that all those button inputs are also detected. So now that the collective is working, there's one last thing I like to do. You could just leave it here and it's perfectly fine and it's perfectly working. I just don't like that it displays the device as an Arduino Micro. And also, if you have other projects that use the Arduino Micros, it might get confusing to identify the two of them. So what I like to do is changing this name. To do so, there's a couple of things that you need to do. You have to go to your documents folder. In your documents folder, there will be an Arduino folder. And in here, you will have all your libraries folders. And you may or may not have a hardware folder here. If you don't, you just create a new folder. I do have one, but it's in a I saved it in a different place for this video. So what I'll do now is just copy my hardware file and paste it here. This hardware file, in my case, I have several folders, but you need to create one for the collective. And this folder has an AVR subfolder. And then inside here, you will have these two files. I will leave them in my Thingiverse for you to download. Essentially, you just need to copy these two, this folder and this file. And this one file, the only thing that you need, there's a couple of things that you need to change. First line where it says name, you give it the name that you want. I like AH-64D collective. Then there's also down here two other values that you need to change. One is the USB product. I named it the same. And also, if you are building more than one device with this technique, you will also want to change the PID, because otherwise they are going to collide between the two of them. And if you plug the two of them together, it's gonna identify them as the same device, and it will not work. So, for instance, I have 8052 for the collective. I have a different one for the TDAC, so 8053 for the TDAC. I have also built MPDs, MPCDs for the Apache, and this one have a different PID, 8045, 54, sorry. I just want to go one up, and that should work. And obviously, the names for each one are different. So let's do that and show you how to do that. Once you have copied this folder into your hardware folder, Arduino, in the Arduino folder, you need to close Arduino and open your sketch again. Since I've already I've already set all these values, I'm going to comment all the serial lines. We don't need those anymore. I'm going to also comment the serial begin in the setup. And then instead of board Arduino Micro, with that folder, now I have all these options. And I can go to the collective one. Here's the AH-64D collective. It's going to be exactly the same as the Arduino Micro, but it will now have this name. So if I upload this sketch, and this is just, you know, an aesthetic thing. I just like it because it looks cool, but it also helps you identify your devices. So if I now go to USB device, instead of Arduino Micro, I have AH-64D collective, and it's easier to identify. So that's it for the series. The collective is done. I hope you enjoy it. I hope you enjoy flying with it. I certainly do. Please let me know what you think in the comments. If you have any questions, I'll be happy to help you. Post them in the comments as well. And thank you for joining. So have a safe flight.